Okay, so hello and welcome back. My name is Imad. Well, I think you knew that already, or maybe you didn't. But anyway, let's get on with this. Okay, so the coordinates of points A, B, and C are -1 and 3, 2 and -4, -4 and 6, and 3 and A respectively. Calculate the value of A if AB is parallel to CD. So, one moment, let me hook up the pen. Okay, and there we've we got to switch on the tablet. Okay, there we go. Right, so let's see what we've got going here. As you know that double line over there means parallel, right? It means that two lines are parallel. Okay, so they're saying AB is parallel to CD. Now, we want to calculate the value of A. So A is between coordinates C and D. So remember that's D. That's at point D, right? That's C, that's B, and that is A over there. So what does this have? How does it help us? Well, let's look at this quickly. C and D. Right, so I can't determine the gradient of C and D there, but I can determine the gradient of AB. So let me do that. Let me say MAB is equal to the following. It's going to be the y's, which is -4, -3, divided by 2, -1. And let's see what I get over there. That's going to be -7 over 3. Now, if that is MAB, if CD is parallel to AB, there's something special about parallel lines. Now, we didn't mention this before, but let's do it over here quickly. Let's see what parallel lines are. So if I take two lines, parallel lines are lines like this. If I draw a line like that there, I draw another line like that there, then I can conclude that these two lines are parallel if I were to take a line like that, and drawing that line would result in meeting at a right angle. Okay, these are parallel lines. Then I can say that this line over here is parallel to this line over there. That's our example of parallel lines. Right, now there's something special about parallel lines. Their inclination or their gradient or their slope are equal. So if this is my line AB over there and this is my line CD, if they meet at a right angle like this, or I can say that the gradients are the same, right, or that these two lines never ever meet, then I can say that these lines are parallel. Now if they are parallel, they have a property. The gradient of MAB is equal to MCD. That's gradients are equivalent. So let's go back to what we had over here. And so if I know the gradient of AB, then the gradient of CD must be equal to the gradient of AB if the lines are parallel. So the next thing I'm going to use, I'm going to say MAB is equal to MCD, and that is equal to -7 over 3. Now from this I can actually construct an equation, right? What's my equation going to be? Well, CD is going to be gradient of CD is equal to the D's. Let's make it A minus 6. And then the x's, right, the y's, d value, and then the x value there, 3 minus -4. Okay, 3 minus -4, and that's going to give me a value of a minus 6 over 3 plus 4, which is going to be 7. Now you may be thinking, well, Imad, you've got A unknown and you've also got MCD unknown, but that's not true because I know MCD, and that's going to be -7 over 3 is equal to a minus 6 divided by +7. And now I can solve. Let's solve this. A little bit of algebra, I throw that in. I'm going to say it's -7 over 3. Okay, let's just put this a little bit higher. -7 over 3 multiplied by 7 plus 6 is equal to a. So let's see, what do we get for that over there? That's -49 divided by 3. I get an answer, and then I add 6. It's going to give me -10.3. Okay, so -10.3 would be the same as -31 over 3. Sorry, that's my fault. That's a fail there. minus 31.3. Okay, and that's the same as saying negative 10 comma 3, 3. So that was the first example. Let's look at B.